Mathematical Literacy Paper 2 that was written today. No. Paper 2, question number 1. Paper 2, question number 1. We need to match. All right. The table 1 below contains a list of explanations and definitions of concepts used in mathematical literacy. A drawing showing streets for a person who drives a car. B, we look at a visual indication of real-life distance and its distance on the map. A boundary, this is C, a boundary that surrounds a circular-shaped object. D, a position which roughly shows the location of an object. E, the sum of the areas of all faces of a 3D object. F, the rate of covering a certain distance. G, the amount of space that is enclosed by the perimeter of an object. All right, let's go there and you see. So of the definitions up, which one represents the concept, which one explains these terms which are given down? They say use table 1 above to write down the letter of the explanation of definition A to G of each of the following. Now we look at a bus scale. What could a bus scale be? A bus scale is B, a visual, so yeah, it's a visual indication of the reason why we are picking that. We are having real life versus distance of the map. You see, and it's visual. All right, so we go on and we say surface area, a sum of all areas. So this one will be E. Roadmap, a drawing showing the streets of a person. So this is A. Speed, the rate of covering a certain distance. It's F. It's a rate. All right, there we go. 1.2.1. Okay, write down how many streets Mr. Machete must cross before turning into Winchester Street. So what we're going to do, we shall identify them. Now, this is where Winchester is, this part here, this street here. So it's from the guest house. How many streets is he going to pass? We pass 1, 2, 3. So there we shall write. They said how many, so we only need to write the number. They didn't tell us to list. Now they go on and we say, all right, there we go. Name the street that goes over the Lippe River. We have the street that goes over. Let's look at the next year. This is the river. Because it's the bridge. Then there's this street that goes up like this. This street is called Ife. I'll write it there. Okay, the total distance from the guest house to the destination. Now we have they're telling you this indicates the distance between two positive marks. So the distance between this and this, it's this much. From here to there, it's this much. From there to there, it's this much, and from here to there, it's that much. So we calculate the distance, and we see we shall add all the distances, which becomes 980 plus 435 plus 870 plus 1,100. And the final answer becomes 3,385. Don't forget the units. Meters. Okay, 1.3. Illustrated below are steps and components needed to assemble a chair. The components to assemble their chair are labeled alphabetically from A to K. All right, these are the steps taken. Okay, go on and say, determine how many different types of screws are needed to assemble the. So screws are here. How many different types? So we have 1, 2, 3. We shall say there are 3 types. Type H, type I, type J. Use the steps to assemble the chair to identify the following. The letter that indicates the chair base. This is the chair base. So it's going to be letter E. The number of screws used in step 4. Number of screws used in step 4. This is step 4. And the screws, you can only see H. And there are 4 of them. There are 4 of them. So we shall say 4 for screws. They say, name the tool needed to assemble the chair. The tool, the only tool that we have, it's Allen key. So we shall write it here. Allen key. Identify the component of the chair that comes as a pair. As a pair. These are the 2 things that we say as a pair. Component. It comes as a pair. So it's F and it's what? The chair arms. That marks the end of question number 1. Let's look at question number 2. Question number 2 says, shown below is the layout plan of a conference room in Pretoria Hotel. So a plan looks like. So here they come and say, define a layout. A layout, we shall say, a drawing showing how items are placed. You can say that. What do you want to know? It's a drawing. It's a plan. It's a layout. It shows how it's supposed to look, how things are going to be arranged. All right, they're saying write down the total number of chairs around the oval shaped table. We have, you come and count. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we have 20 chairs. We have 20. We have 20 chairs. Which one of the following statement regarding the conference room is true? First, the screen is on the eastern side of the room. The moment you hear of direction, look, where is the compass? Now the compass shows that this is the north. This side is the north, definitely. The upper part is going to be the south. Now, if this is the north, the south, that means this is what? The west. And this is the east. So they are saying the screen is on the eastern side of the room. No, this dies. Then they say the screen covers a window. This is the screen here, it does not cover any window. So this is also false. Then the screen is the opposite. Okay, is opposite the door leading to the room. Opposite, opposite, opposite. You see, this is the screen and this is the door. So the right answer there is supposed to be C. It's true. Give one possible reason why plants are not placed on the table on the northern side of the room. One, it's for a clear view. These people are far away from the oval table, so they need to be this other side. So for a clear vision to see whatever is going on the oval table. Here they're telling us the actual length of the conference is 12. Measure the outside length of the conference room on the layout plan. So you have to come here. You had to measure from here to this other side here. We shall measure and we shall get different. Now I got 125 meters. This is what I've measured. So we shall come here. They are telling us. Hence, calculate the scale used. So on the map, it's 125. In real life, it's 12 meters. So changing the meters to millimeters, multiply by 1,000. So now the scale is 125 is to 1,000. It's 12,000. Why am I multiplying by 100? Sorry, 1,000 because I want it to become millimeters. So I divide through by 125, divide through by 125. And the answer becomes 96. .2. A single layer of bottled water will be packed on the rectangular base. The packed bottled water will occupy half of the length of the rectangular refreshment table and will not overlap the edges of the table. That means it won't reach the edges of the table. So here we go. We say shown below are the pictures and the dimension of the top, the rectangular. All right. I get the maximum number of packed bottled water that can fit on the half of the table. So here we go. Want to find out how many will fit here. And how many will fit on this other side. So we shall look for how many will fit on the long side, lengthwise, but remember the length is divided into 2. So we need to first do this. And it becomes 140 centimeters, 145. So divide by the length of the bottle. So this will be so on the long side, shall say, 1, I had to look for half the length. So I found out it's this much. Then I'm finding out how many bottles shall we have on that longer side. So this gives us 3,98. So since we don't have a half a box, we shall take it to be 3. We shall have 3. Then what about on the short side? The short side, we shall have the width, which is 49 divided by the width of the table. 49 divided by 22,2, end up having have 2. We have 2. So all in all, we have 2 and 6. 3 times 2, and the answer becomes what? 6. 6 packs. So we have 6, 6, 6 packed bottles. All right. We go to our next chart E. Sorry, next chart A. Next chart A looks like this. Then we go to the questions. It says next chart A is a road map and area information directing the conference attendees to the Pretoria Hotel. So use the next chart A to answer the questions that follow. State the general direction of Amber Road off ramp from the Fountain Circle. We have, this is the off ramp here. Here we are. Here we are. Then we are coming from this Fountain Circle here. Then what you have to take note of, this side is the north. So if you're here, if you're here, you need to know which direction is it, which will be south, what, east. Because if we are here and you draw the compass like, because this is north, east, then what? South. So it's southeast. Southeast. Explain. Explain. Explain the phrase map is not on the scale. Map is not on the scale simply means not on scale. It simply means uh, it's not drawn from the actual map. Not drawn. It's not on scale. It's not perfect. It's a sketch. It's a rough work. You understand? Then they are saying complete. Pretoria Hotel is at the corner of Dash and Dash Streets. So we go there and we see Pretoria Hotel. Take note how I go to, because when you check on the map, you can't see it. But you see Pretoria Hotel 193. So 193, it's this place here. So which streets are they? So we say it's Kroof Street and Albert Street. Shall go there, complete, and we should say it's Kroof and Albert Street. All right. State the probability of having a traffic light at Brooklyn Circle. We look for Brooklyn Circle, which is this one here. So we don't have any chance of having a traffic light there. So we shall come here and you say it's 0. It's 0. Give one reason why some streets are numbered 1 to 7. We can say to be easily identified or easily seen, clearly seen. Or if not, they carry a lot of, these are the main streets around the hotel. All right, there we go. Let's look at the 2.3.6. Receptions at the Pretoria Hotel has to report for work by 5:30. So she takes 10 minutes walk from her place. This is the first time. Then she leaves her house. She lives at the house at that time. Then she takes 10 minutes, which is already now. This means she'll leave and reach to wait for the taxi. By then, 10 minutes, it will be around 5:05, plus the 20 minutes ride in a taxi. Then plus now the 20 minutes will become now 5:25. And the last one, the 5 minutes, which becomes 5. So the statement is what? The statement is valid. How? She wakes up at this much time. She leaves the house at this much time. She spends 10 minutes walking to the bus stop, plus the 20 minutes inside the taxi, plus the 5 minutes off the taxi to the hotel. When you add this, you end up having 4:55 plus 35 minutes, right? The 5 minutes plus this becomes 5 exactly. So this other side you're running with that, which becomes what? That. You add up this time. If not, someone would have done this. Add on 10, what do you get? It said you get 5 past 5. Not so? 5 past 5. Then you add on the 20 in the taxi. So that's 5:25. You add on the 5 minutes walk from the taxi stop to the office. Indeed, it becomes 5:30. All right? Leave the house. You ride. You walk to the office. Okay, that comes to the end of question number 2. Look at question number 3. Andrew and Duncan went fishing for carp on a friend's farm. Note, carp is a large freshwater fish that can be eaten by humans. All right, 30.1.1. A female carp can lay 2.7 million eggs. Write 2.7 million eggs in full using numerals. Now they want it in numbers, which would be 7, that much million. So if you want it in numbers straight away, just multiply by 1 million. When you multiply by 1 million, you will end up having even with 5 zeros. All right, let's go on and be saying 3.1.2. Andrew caught a catfish with a mass of 2.375 kg. Duncan caught 2 catfish, one weighing 1.2 kg and the other is 750 grams. Determine in kg the total mass of the carps they caught. So all you're going to do is to add. All you do, you add. All right, since we are looking at the total and has to be in kg, first thing you do, change this to kg. We divide by 1,000. This became 0.75. So you add everything up now, which becomes 2.375 plus 1.2 plus 0.75. All right, there we go. You have your answer as 4.325 kg. Don't forget the units. Units are more important. Units are important. All right, let's continue. We look at question number 3.2.1. Okay, 3.2. Andrew wants to erect a very pretty wall on the boundary of his property, a perimeter. He wants to put a fence. Then the wall will consist of concrete posts with precast concrete slabs between them. The wall will have 12 posts planted into the ground using concrete. On top of each post, he will place a post cap for each post and digs a square hole in the ground with a side length of 30 centimeters with a depth of 60 centimeters. They are asking us, use the information above to answer the questions that follow. They want us to calculate in meters cubed the total capacity of all the holes dug for the required posts. Now remember, volume equals, but then they want it in meters cubed. The measurements we have are in centimeters. All right, what we're going to do is to first change them to meters. So 30, we divide by 100, comes 0.3. These are meters. Then the 60 also be divided by 100 and becomes 0.6 meters. So we shall substitute in the formula here. We say volume will equal to 0.6 times 0.3 times 0.3. The reason why I'm repeating these two, it's a square. Take note of that, it's a square. So meaning the length is the same as the breadth. So we go on and we shall say 0.6 times 0.3. So the answer here becomes 0, these are meters what? Cubed. But only this is for only one. What happens next? For 12 of them, multiply by 12. And the answer will become 0.648 meters cubed. All right. We go on and we say, Andrew mixed the same volume of concrete as the volume calculated in 3.2.1. Give an explanation why he had some concrete left over after planting the posts. This one we shall work on the law of physics that states that body immersed in water displaces the same volume. So remember, the concrete is going to be put in the hole. Then the hole we shall put the post. That means the concrete had to overflow. You understand? The concrete, the one he was supposed to mix less concrete because some part will be taken by the post. Some part will be taken by the post. The post occupies or the posts occupied some space within the concrete, so it had to overflow. It had to overflow. It's just like you filling up a cup with water and you insert your hand. Definitely, that water will have to overflow. Why? The hand has taken some space. All right, these are 6 marks. We look at this. They want us to do what? Calculate the mass of the river sand needed to make 1 millimeter cubed of concrete. Now, what you're going to do, it's here. They have told you 0.75 meters cubed. You will need 5 bags. You see that? But they are saying, let's calculate the mass of river sand. This one here. Need to make one. So we shall go back and you say, yes, we shall say 1 bag, 1 bag gives you 2 wheelbarrows. See that? 2 wheelbarrows. Then what about if you have 55? How many wheelbarrows would you need? You will need to multiply. Multiply that becomes 11. So we shall need 11 wheelbarrows. Wheelbarrows. But then these are wheelbarrows. We are not interested in the wheelbarrows. We are interested in 1 meter, 1 meter, 1 meter, 1 meter cubed. So they have told you 0, it takes 5. What about 1? Let's also look at that. We shall say 1 meter cubed gives you, we don't know, but the 0.75, they will need 5.5. You see that? So we shall cross multiply. We need to find out how many bags we need here. Cross multiply simply meaning we shall divide 55 divided by 0.75. So you end up having 7.5. 3, 3. These will be what? Bags of cement. But remember, one bag, it takes 2 wheelbarrows. What about the 7? So 7,73, we shall multiply it by 2. Actually, these bags, we can't have 1.5. Probably it's 8. 8 bags. Eight bags. 8 bags. So 8 bags we multiply by 2, we shall end up having 18. Why am I multiplying by 2? Because I'm looking for the number of wheelbarrows. So I will end up having 16 wheelbarrows, and each has 1 and 2 kilograms. So at the end, they will have 1,632 kgs. That's what they want. They calculate the mass. It said the mass. And you've seen the mass is this one here. For one level wheelbarrow. So we needed to find out how many wheelbarrows do we need. All right. Look for the number of bags that we need. How? From this statement here. Zero 0.75 meters cubed. They give us 5.5 bags. Now, what about if you have 1 meter cubed? How many bags will you have? I'm looking for the number of bags. These ones will lead me to the number of wheelbarrows that I need. So this simply means I will cross multiply. This multiplies with that. This multiplies with that. At the end, I need to divide 55 divided by 0.75. I end up having 7, I end up having which is approximately what? 8 bags of cement. So here it says if you have 1, you have 2 wheelbarrows. Now I have 8 bags. That means I need 16. But each wheelbarrow is this much. So I'll get my 16 and it's that much. And the answer will become 1,600. The mass is this one here. For one level wheelbarrow. So we needed to find out how many wheelbarrows do we need. All right. Zero 0.75 meters cubed. They give us 5.5 bags. Now, what about if you have 1 meter cubed? How many bags will you have? I'm looking for the number of bags. These ones will lead me to the number of wheelbarrows that I need. So this simply means I will cross multiply. This multiplies with that. This multiplies with that. At the end, I need to divide 55 divided by 0.75. I end up having 7, I end up having which is approximately what? 8 bags of cement. So here it says if you have 1, you have 2 wheelbarrows. Now I have 8 bags. That means I need 16. But each wheelbarrow is this much. So I'll get my 16 times that much. And the answer will become 1,632 kilograms. Three point three, we look at measurements still. We look at measurements. Number 3.3, we say the square-based post cap has a side length of 15,24 centimeters and a constant height of 2,5 centimeters. The perpendicular height of the triangular face is 7,8 centimeters, 86 centimeters, as shown in the diagram above, alongside, sorry. Okay, now we go on and we say the net of the faces of one of the post caps to be painted. These faces are going to be painted. All right. Then we go. Andrew wants to paint the two sides of each concrete post. Each concrete post has a dimension of 125 millimeters wide and 1,6 meters long. And all the outside faces of the post caps. All right, there we go. They are asking us, calculate in centimeters squared the total area of all post sides that have to be painted. Post sides. Remember, the post side, if we have it here, the post side, they are going to two sides of the concrete posts. The measurements are here. You understand? I'm here looking at it, you just see that because this is the width and this is the length. So we're going to use this area here, but two sides. So, meaning area of only one side will be, remember they said in centimeters, these are meters, these are millimeters. You need to change. The width will have to change to 1 comma. You divide it by 10, becomes 12,5 centimeters. And the length is 1 comma meter. You need to multiply by 100. The answer becomes 160. These are, before you do anything, they have to be the same units. So we shall come and substitute here, length times breadth times height, which is area equals to 160 times 12,5. What answer do you end up having? 2,000. Remember, they said all the post sides. So there are 12 of them. Multiply by 12, you get 24,000. Again, you multiply by 2 because there are two sides. You end up having 48,000 centimeters squared. Don't forget that, please, the units. Units, units, units. Okay, that's done. Now they go ahead and tell us, Duncan stated that the total area of all the posts and the post caps to be painted was 52,704 centimeters squared, rounded off to the nearest whole number. Verify showing all calculations. Let's find out this. Now, they are telling us when you get the area of the posts to be is post size and the post cap, you add it together, it will give you this much. Yes, we already have the one for the post. We've not got the one for postcards. All right, let's do that and we see. The postcard will look like this. This is the area. So how many triangles are they? We have 1, 2, 3, 4. So we shall look for the area of only one triangle multiplied by 4. How many rectangles are there? We have 1, 2, 3, 4. Also, we shall look for that multiplied by 4. That's only one. The area we shall get there, that will be the area for only one post cap. All right, let's do that and we see. So if I'm to find the area of the triangles only, I'll start with area of the triangle. I know very well it's a half base height, which will be half times, what's the base? The base is this number here, from there to there. So I'll put it there, 15,24 times 7,86. And the answer becomes answer becomes 59,9. These are centimeters what? Squared. So what we're going to do, we keep it there. Then also we find the area of the rectangular part now, the base. This one's here. At first we are looking for this triangle, but there are 4 of them. Then what about the area? I want to look for only one side. Also we have this, the rectangular. So we shall say L times B, which is 15,24 times 2,5. 15,24 times 2,5. Right. So these two, they make one cup. So let's add them together. We shall need the total area of the cup. So we shall need, we shall say that 8,1 plus 59,9. We have the answer as 98 centimeters squared. But remember, these are going to be applied on the 12 posts. So we shall multiply by 12. And times 4. Remember, there are 4 triangles. You're supposed to multiply here by 4. Must supposed to multiply there by 4. So you end up having 4,000. This is the area for only the post caps. Then plus the area of the post, sides. Indeed, the answer becomes 52,000 centimeters squared. You had to look at that. 1, look at the triangles only. 2, look at the area that makes the posts. You understand? Okay. 3.3.3. The spread rate of paint is 12,46 liters per meter squared. Calculate how many liters of paint is needed to paint. Now, take note of this. We have per meter squared. These are centimeters squared. So we need to change, or a meter squared, because now remember, if you have a centimeter, sorry, if you have a meter, you have 100 centimeters. What about if you have a square meter? You have 100 squared, which is approximately 10,000 centimeters squared. You understand? 10,000 centimeters squared. So I'm explaining this. This simply means for every 10,000 centimeters squared, I need 12 liters 46. I need 12,46 liters of paint. So now I have 52,704 centimeters squared. How much will I need? Definitely it's going to be more, because for 10,000 only I need 12. What about 50,000? I need to cross multiply. I divide by that much. So here I need to cross. So this simply means it will be 52 times 12,6 divided by 10,000. We look at question number 4. A program inspiring people of all ages and genders usually ends with a fashion show. The next year, this shows the layout of a runways and the seating arrangement at the fashion show. Next to the floor runway, a single seat arranged in rows. Each round table next to the raised runway can seat a maximum of 10 people. It can accommodate a maximum of 10 people. Each of the runway is 4 feet 4 feet wide. Each of the runway is 4 feet wide. Here we go. They want us to do what? Write in simplified form the ratio of the width of the width to the length of the raised. Now, they have told you each of the runway is 4 feet wide. So we are looking for the ratio of the width to length. We shall use the annexure. So here we are. Is 4 feet. So this is the raised. So in simple terms, what are we looking at? We shall be looking at 4 is to 24. Simplified 4, the same as 1 is to 6. Convert the length of the floor runway to meters. We are converting the length of the floor runway to meters. They have already told you that if you have 1 meter, you have all right. Now we're going to convert the length of the runway. We convert the length of the runway to meters. Remember, it's already in feet. So we need to change and say, okay, the length is 54 feet. It has to become meters. They have already told you if you have 1 meter, you have 3,28084 feet. Now in this scenario, you have feet. What are they in meters? I will cross multiply, right? This, mere looking at it, I need to divide at the end. So let me divide straight away. So it's going to be 54 divided by 3. 54 divided by 3, 28084. It's for 6. These are meters now. Becomes 16. 16,4, 6. 16,46. They say that the runway to meter, they didn't say it was, so it's fine, either though you don't round up to the nearest number. Give a possible reason for each of the following. Why is the second and the third row seats not arranged exactly behind the first row seats? This is so simple to allow a clear view, for those behind row 1 and 2. This is so simple. If there's a seat here, there's another seat, there's a seat, so definitely for someone to view through this, you have to put another person, the person will have to sit here, in that they can see through this without standing up. You understand? The same story will happen here. It will be, you move them also. The third rows you also have to move, in that they can see clearly through like that, right? Without them moving up and down. That's why they seated like that. And these are why they're saying, this simply means to allow access to the raised runway, raised runway. The diameter of the round table is that much. You may use the following formula in the question that follow. Area of a circle equals to that, circumference of a circle equals to that. Calculate the area of the top of one round table. Now you know very well area of a circle will equal to what? Area equals to pi r what? Squared. That, but you needed to find the radius by dividing the diameter by 2. I've already told you the diameter is 1,8288. We divide this by 2, you end up having 0,9144. This is the radius. Then you come and substitute it here. Pi, it's always 3,142 times 0,144. Don't forget, it's supposed to be squared. All right, there we go. 3,142 times 0,144 squared. You get the answer as 2,63. These are meters squared. These are meters squared. Then that was part A. This is part A. Part B. Each person occupies an equal length of the outer edge of the rounded off. When you hear outer edge, so simply meaning On the edge, this is going to be what? The circumference. Going to be the circumference divided by the number of people on each table. All right, so now we're going to use, it says circumference equals to pi d, which is the same as all right. So we do that. Divide this by 10. So each person takes 0, 0,57. The girls participating in the fashion show need dresses that fit well. The fashion show uses an equal number of girls for each size, an equal number of girls for each size, an equal number of girls for each size. Next, just C shows a body type chart used to select the correct dress size. Use annexure C and the information above to answer the question that follows. Write down the write down the body size of a girl with a mass of 55 kg and a height of 1,6 meters. So we shall use the next year. All right. We are looking at 55 kg and the height of 1,6. We come here. 55 kg, the height of 1,6. So what is the size? Extra small. The size here will be extra small. Write down the body size for a girl with a mass of 55 kg at a height of 1,6 meters. So we said X is. Someone might have written that. It's fine. Extra small. Now they're telling us state the mass of a girl whose height is 1,75 meters, wearing a dress size 14:2. So height 1,75 meters, wearing a dress of 14:16. We come here. Let's highlight. Height of this much, wearing a dress of this much. You see that? The dress here, the dress size. So the mass is supposed to be what? 8. 8 kg. So they are telling us calculate the body mass index of a girl who weighs 70 kg and is. So body mass index, everything has to be in, okay. The mass has to be in kilograms and the height has to be in meters. The mass is in kilograms, check. The height is in meters, check. So all we do is to substitute. The mass is 70 divided by 1,50 squared. And your answer became, please don't forget the units. Don't forget the units. It's the answer is 31,11 kilogram per meter squared. Write down as a percentage the probability of randomly selecting a girl who weighs 50 kg and wears extra small. Probability. Picking a girl who weighs 50 kilograms and wears extra small dresses. So we shall come here. First and foremost, identify what we are looking for. The girl should weigh 50. And she puts on extra. So here we are. We have how many are they? Because this is where so we have 1, 2, 3, 4, 5, 6 out of all these girls who are chosen. Remember, there are 6 girls for each type of for each size. All right, or for each mass. So we have 6 out of how many are they altogether? So we shall count and find out. So if these are 6, so we count going this side, I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So all in all, there are 66. So probability as a percentage is going to be 6 out of 66 because they mentioned the percentage here. We multiply by 100, which will be 9.09%. Don't forget that because probability, the answer lies between 0 and 1, or 0 and 100%. All right. Bonolo stated that the probability of randomly selecting a girl wearing a dress with a body size smaller than extra large is 0.833. Verify with calculation whether statement is valid. Now we are looking for girls who will be putting on smaller than XX. So we shall come and we see, count ourselves here. We see how many girls have extra large here. We shall say these are all 6. Ne? So what do you remain with? You remain with 59 out of 66. Sorry, you remain with 60 out of 66 because the 6 are out. Right? The 6 are out. The 6 are out. So what's remaining? You're remaining with 60. These ones are below. Extra is smaller than extra large. So we shall come here and we say we are proving. So if it's not this much, so we shall say 60 out of 66. Express it as a decimal. Which is 0.9. The statement is what? The statement is valid. Let's still look at question number 5. Ice is usually used in cool drinks to further cool them. Ice can be made by freezing water in different shapes. Cubes are the most common shape used to make ice. Use the information above to answer the questions that follow. Determine the surface area of a cube. Now remember, a cube has 6 sides and they're all equal. So all you do, look for the area of only one side, then multiply it by 6. So, and it's made of squares. So area of only one side it's going to be 4, 5 squared. 4,5 squared. You get your answer as 20,25. This 20,25, how many sides are they? Times 6. And the answer became centimeters squared. That's right. Determine the surface area of a cube. That's what they wanted you to do. 3 marks. Substitution, please don't forget the units. Don't forget the units. Always. All right, calculate the total mass in kilograms of a wall built with 60 big blocks of ice. Now, what are we going to do? They said mass in kilograms. And I've told you 1 kilogram is equivalent to 0,01 ton. So the 60 big blocks, each weighs 2 tons. So in other words, here you have 120 tons. These 120 tons, we need them to become kilograms. So we shall divide by 0,01. You get your answer as get your answers. 120,000. These are kilograms. But for someone who already, now, where do we get the 2 from? The 2 comes from here. Are made of big blocks of ice, each weighing 2 tons. You know, whenever we know a ton will always equal to 1,000, what? 1,000 kilograms. A ton will always weigh 1,000 kilograms. So this is it. So that was supposed to be the answer. We are saying 1 ton is equivalent to 1,000 kilograms. So if 60 were used, okay, 2 tons, that means it's 2,000 tons. Multiply by 60, you end up having the same answer. All right, question number 5.2.2, a block of ice was carved out to make a circular opening. The carved out ice was melted, resulting in water with a volume of 38,500 centimeters cubed. Calculate the volume of the ice that was carved out. You may use the formula below. Now, what I want you to take note of, you have volume for water equals to volume for ice times 0,92. So you already have volume of water given to you. So you have to just do this equals to volume of ice times 0, because you're looking for this ice here, we shall divide through by. So the volume of ice will be 38 divided by 0.92. Which is 41,847. They say round up to the nearest 47,83 centimeters cubed.
Hi, Pussy. Please send your proof of payment urgently, please. They want to disconnect the power now. Thank you.
Right, 5.3, we look at an extra D. You're saying they're telling us Alaska is one of the states in USA. Anchorage is the largest city in Alaska. The next D shows the parts of the globe indicating the shortest distances in nautical miles between Anchorage and a few selected cities in the world. 1 nautical mile equals to 1,15 miles, then 1 kilometer equals to 0,6215 miles. Use an extra D and use the information above to answer the questions that follow. They're asking us to determine the nautical miles difference. Now, here we go. We're looking at the difference between Tokyo to Nauru. Then another one is the distance there. You're looking for the difference. So first and foremost, we shall have to identify the distance between Tokyo and we shall look for the distance here. So we are looking at Tokyo. So this is the first one. And Anchorage and then Washington and okay, here is Washington and so what's the difference? So meaning we need to subtract, which will become 3,500 minus 2,900. 3,350 minus 2,900. And the answer became all right. We took that distance there. And it was 3,000 350. We subtracted 2,900. And the answer became 400 miles. Sorry. By the convert to kilometers. This is between Berlin and Nanook. All right, there we go. We see, find out Berlin is up here. Then this is the place. So the distance we're looking at is this. We need to convert this to kilometers. That's what they're telling us to do. We come here and we say it's 30,000. We saw it as 30,000. 3,950. We need to change it to kilometers. In kilometers, they have told us. In kilometers, they have told us we need to change this to miles. So first and foremost, we change this to miles, which will be 1 mile equals to that much. So we shall multiply this by 1,15. We get the answer there. It becomes 4,546.45. Now these are miles, but we need to change them to kilometers. So we shall divide by 0,6215. $7,300. Is an hour, kilometers. First change to miles, then miles to kilometers. That's what we are doing. That's what we did. Cargo needs to be shipped from Los Angeles to Nahum, then from there to Tokyo. Penyo searched the internet, searched from the internet, right? To determine how long it would take the cargo to reach its destination. Shown below is a research result, and some information has been omitted. This one here, there's no information there. Some omitted, some information has been removed, some information is missing. So it's this part here that we're looking at. Anyway, let's follow the questions. Calculate this average speed of the ship rounded to 2 decimal places. So first and foremost, we are looking for speed. Look at the formula they've given us, it's fake. So we shall say speed equals to distance over time. This is the right formula here. So we ask ourselves, do we have the distance? Yes. Do we have the time? Yes. But the time has to be in hours. Everything has to change to hours. Why am I changing to hours? Because I want the answer to be nautical miles per hour. Nautical miles per hour. So first and foremost, I will need to change my time to hours. Time to hours. Remember, the person moved 10. These are 10 days. 10 days and 4 hours. So the 4 is already hours. So we need to change the 10 days, which is multiplied by 24. Because I told you, travels 24 hours plus the 4. So the hours here, it's 244 hours. So this is good. Now the distance, so now we shall go and we find the speed, which will become the distance 2060 divided by 244. 244 This became 10,6. These are nautical miles per hour. That's the speed they are traveling at. All right, 4 marks. Part B, the last question, yeah? It says, hence determine the date and time of arrival in Tokyo if the ship leaves Nauru on the 24th of September at 16 hours and sails at the same speed. So now, this simply means speed, we already have it. They're telling us it's 10 nautic miles, 10,6 nautic miles per hour. So the speed, we already have it. Distance covered, we have it as 3,350. Distance covered, we have it already. So what's missing? It's the time. How much time did they spend? This is missing. Okay, we shall say now the time will equals to distance divided by speed, which is 3,350 divided by 10, comma. So what answer do we get there? So we get the answers 3,13. So these are hours. We turn them into days, divide by 24. The ship spent 13 days, 0.96005. What do we do? This now we know already. We have 13 days. So whatever remains, we change it to hours. So we subtract 13 from there, you remember 0.069.